In the overwhelming majority, the stars are not alone and form double and even triple systems. Moreover, they exist in clusters, and even in associations of several 1,000 stars. However, there is not always interaction between them. It may be weak, gravitational, or not to be at all, because they were born from one molecular cloud. The closest community like this to us is located 450 light-years away, in the vicinity of two constellations Centaurus and Scorpius. The association received its name accordingly. Scorpio-Centauri Association. This is a star association, star formation region. This is a gigantic family of relatively young stars, giants, most of which are only 11 to 15 million years old. All types of luminaries available, from brown dwarf substars, which did not have enough mass for thermonuclear fusion, to the giants. Of course, there are also red giants like Antares, Alpha Scorpio, on the verge of a supernova. Some stars have long since burned out, so with quite ordinary stars. In this vastness, in the star stream, the frost and throne stars fly, and black holes. New association Scorpio-Centaurus, formed from dense gas-field clouds. Several 1 million years ago, gravitational forces further compressed the clouds. They collapsed, giving birth to protostars. When the first lights lit up, their gravitational interaction was quite chaotic. There was not a single sign that the stars were in balance, such as compact, globular clusters or stable orbits. The association began to disintegrate into three streams, in which there was still no place for gravitational connection and balance. Some stars emerged into multiple systems, but their interaction still resisted the creation of stable structures, and therefore everywhere supernovas flared up, further destroying connection of components in a system. Someone got an extra velocity vector, and he was thrown out of the stream, and some were simply torn to shreds. These supernovae are one-day blue giants who live such a short life that even the geological era on Earth does not have time to change, such as a rule planets do not have. There were planets near neutron stars. Only these were the remains of the cores of the dead stellar giants, preserved only thanks to that were at a very decent distance from them. Mostly exoplanets live near red dwarfs, or yellow like our sun. We're even near pulsars, but never near the bright giants, with compatibility class O, in which supernovas are about to explode. That's why a protoplanetary field disk around such a star flies into space before anything has time to take shape in it. Until the recent discovery, there is in the association of Scorpio-Centaur one blue-white giant with a mass of about 9 solar ms. 2 Scorpios. He is very young, no more than 19 million years. This means that it will soon turn into a supernova. But here's a Chilean Vera Large Telescope, and the Gaia Space Observatory saw the star address on this deathbed. As many as 2 potential exoplanets, which in principle shouldn't happen. One of them, according to scientists, 1830 times more massive than Jupiter, and the other one is 14.4 times. First is closer and gets so much star energy. How much do we have Mercury? The position of the distant one is more similar to the position of Jupiter. This planetary system, it reminded them very much of our solar, only in enlarged format. As an option, these exoplanet candidates may not be exoplanets. They are so heavy, which are more like brown dwarfs. Although the difference between these classes of objects, very vague, and all the proportions between the mass of the planets and the mass of the star, practically, do not differ from the relationship between the Sun and Jupiter. Thus, this is the first confirmation of existence. Planetary system around a star. which will become a supernova in the future. Sphere.